Okay, guys. Abigail, you hear me? Yep, you good? Okay, thank you. All right, so a couple of things. If you have not already done it, send me your height, or as some of you might say, height, in feet and inches. Just chat room it to me. This has absolutely no bearing on anything. Don't worry, I'm not taking any names or anything like that. But so just chat room it to me if nothing else. This is either going to work out really well or it's going to work out really poorly. It's okay. But all right, so a couple of things. I realized, Christy or Abigail, you can give me a heads up on this. I think I forgot to put an extra credit question on the exam last week that I would have given you like the first week of class. So is that, am I right about that?
You forgot
Okay,
it.
it'll be coming back. So I'll tell you about that in a little bit. But um, so thank you, Bradrick. So there'll be another extra credit question off of that song. Now, Christy might know this. Sorry, Christy. But nobody else. Sorry, but don't worry. I'm older than you. But so, do y'all know? Other than Christy, Abigail, you're unlucky in that your camera's up and you're on the first row. So, do you know what the day the music died is? Do y'all know what that? Does anybody know what that is? You all equally disappoint me. Okay, no, it's okay. Okay, so the day the music died, and the question will be, who's the most famous person to die on the day the music died? Anybody know that? No, that's okay. What's that? It's not John Lennon. Buddy Holly. Okay, Buddy Holly. He's the most famous person, probably. Most people would say he's the most famous person to die on the day the music died. Buddy Holly and Richie Valens, who sang La Bamba. Buddy Holly sang Peggy Sue, among other things. And Buddy Holly was the 60s version of, he was going to be the next greatest thing. And then the guy named the Big Bopper, he was also a DJ, but they all died in this plane crash, and that's what they called the day the music died. It was kind of part of the 60s. So that question will be around at some point in time. Who's the most famous person to die on the day the music died? That would be Buddy Holly. Okay, so write that down. I will make sure that I pay you back on that. Guys, I'm doing some catching up, so please don't ask me about the test. It's going to be graded tonight. I promise you that. I just ran out of time today to finish it up, and I didn't want to rush it. And then there will be some kind of remediation for exam one. I'll offer something like that, so don't sweat it too much. Exam one, everybody's doing okay, about where I wanted them to be, so I feel pretty good about it. Okay, but everything else now will point towards exam two and on out into the second half of the semester. If you've finished up your article, which everybody generally has, I realized later that some of y'all, I should have had you just search term with the actual abbreviations. That would have pointed you in the right direction. So some of y'all got crossed up. And so if you sent me the wrong journal, I took 0.1% off, which amounts to like 0.3% of your grade. You can fix it if you want. Like, I really don't think it's going to affect any of you guys. Like, if you're that close at the end of the semester, I'll do something about it. Okay, but the main reason why I did that was to, make sure y'all were not in just some crazy journal. Most of y'all, almost all of y'all picked an article that just, the main thing is you got to make sure that you understand what they're talking about, because you're going to have to talk to me about it. And if you're making stuff up, I'm going to find out. Okay, so there will be directions coming on that very soon. We'll do a talk on that, something next week. Okay, so don't sweat it. I just got to get home tonight and write it up. If you have questions about the article, stick around after class. I'll be here. We have spring break coming up this Friday. Yeah, of course we wouldn't have had class anyway, but so today will be, some pretty important stuff, and then I'll bridge some stuff over on Wednesday, and then you're free to go. You don't have anything due this week unless you're remediating an article. You don't have anything due or anything like that, I don't think. Christy, am I right about that? Nothing sticks out, right? Yeah, okay. Okay, so guys, we're going to turn our attention to the second half here, and this is where things can kind of get a little dicey. I mean, not really dicey, but just kind of goofy looking. So we want to make sure we go really slow here. Now, Christy, what are you seeing right now? Nothing?
You in the library.
Okay, fine. Hang on a minute. All right, not that that's not a lovely picture, I'm sure, but that's okay. Hang on a minute. Let's see here. Hang on. I'm just gonna get this fixed. Now, what are you seeing? Still me, or is it the PowerPoint now?
It's the PowerPoint now.
PowerPoint. Okay. So, guys, you should have notes that look like this, and it's gonna be, it doesn't look like this because you can't see the library, but it's going to have the normal distribution at the top, and it'll have some histograms down here and stuff. Okay. So here's the deal. I'm going to go really slow on this because a lot of you guys have not ever seen this before. And so I'm going to really go slow. So if I make stuff up as I go along, there's a reason for that. It's because I want to make sure that you're getting it down. So if I look off camera every once in a while, it's because I'm looking over here at my other screen. So I apologize. I don't like to do that unless I have to, but I want to make sure that I'm doing things right. So, and if I go off base, Christy or Carl or whatever, just wave at me or interrupt me or something. Okay. So I gave you major concepts at the top of those notes. And yeah, we're just going to, so by the time we get done with this talking about normal distribution, you need to be able to, number one, you need to be able to know what the very basic definition of a normal distribution is, okay? So if you don't know what that is, you should at least in your mind be able to picture that by the time we get done, okay? And, don't overthink that. Just go with what I kind of tell you. You need to know what affects the distribution and what can tend to basically screw it up, okay? So, if you need to think of it in terms of make it non-normal, if you need to write in here, in other words, what can screw it up, do that, okay? Like, don't overthink this. Like if non-normal, you guys need to know, what normal is so you can understand what non-normal is so that you can know what screws it up, okay? You also need to know like the basic reason why there is value in a set of data being normally distributed, okay? So I will explain to you the reasons why we care about whether data is normally distributed, okay? You also need to know what a z-score is, okay, and what the difference is between like a raw score and a z-score. Christy, do you know what a z-score is?
I do.
Okay.
I can't tell you in terms at the second. I have.
Okay, that's fine. That's fine. That's fine. No, that's good. That's good. So that's fine. That's good. All right. All right. Yeah, and kind of going along with that, you need to know what the very basic interpretation of what a z-score means. I'm not really going to ask you to calculate it as much because a calculator can do that. All right. I mean, kind of. All right. But I want you to know what it means. This is the more important thing. Guys, if you get out of here and don't know why we care about a z-score, then I've failed. Now, I'm not going to fess up that I failed. It's going to be on you because you haven't listened, but I'll just go on and say, all right, so you guys, you got to know this, okay? It's not that hard. If you're not getting it, it's because you're probably making it too hard and haven't asked me questions when I might have made it too hard. Okay, so make sure you understand it. And then finally, anything else I emphasize, okay? So we'll go slow here today just to make sure that I don't run over you too much, okay? All right. Take a breath. Okay, so what is the normal? Let me erase all these. What is the normal distribution? Let me see if I can get this erased. There we go. Okay. So what is the normal distribution? The normal distribution, it represents it's the distribution of really the variables or the data in a data set. So all it is, and really, like if you want to write in here, like, I mean, I'm going to say the best or, best or typical. Okay. Or typical. Okay. That's probably a better word, is typical. So make sure you write that in there. It's the best or typical distribution of those variables or those values. And I'm writing that in here, in a data set. Okay. So like when I'm asking you guys how tall you are, every one of you that gave me your height, that's a data point. Christy, Carl, Theodore, Bradrick, etc. That's a data point. Okay. And I'll farm all that data. And then usually that'll give us a normal distribution. I'll show you in a minute what we kind of mean by that, right? And we look at that by using a histogram. So guys, you've got a histogram there, like right down below, and it's a little hard to see because the type is so small, okay? But we'll talk about this in a second. A histogram, so you observe that using a histogram, and a histogram, it looks similar to a bar graph, but they plot the frequency of scores within a given range. Okay, so you're right there, just filling in those blanks. So you plot the frequency of the scores within a given range. Okay, so hang on, don't go anywhere. I'm going to probably come back. Yeah, so you're plotting the frequency of the scores within a given range. So let's look here, and y'all can probably see a little bit better than I can actually, as far as if you're looking on the screen. But so Carl, look at that. Look at, here's your bar graph here, your bar graphs right here. So on your paper there, guys, so Carl, how many counts do we have between 3 and 3.5? Here's 3 and 3.5 would be right here. So how many do we have? Can you see?
Yes. Can you ask that question again, please?
Yeah. So right over here, here's how frequently they occur. 1, 2, 3, 4, 5. You see that? Okay.
Mm-hmm.
And then here's the 3 to 3.5 kind of bin or box. Can you see how many times we have there?
Yeah.
How many is it?
1.
Yeah, it's 1, guys. Okay, good. All right, Christy, we're coming at you. So 3.5 to 4. So guys, you should be writing this in on your paper. That you'll see how this works. Between 3.5 and 4, how many we got?
2.
That's 2, right? Okay. Christina, can you hear me? Unmute yourself, hopefully. Okay. Guys, I'm gonna be coming at you, so if you're not paying attention, just be aware. Christina, how many do we have between 4 and 4.5? That's right here. Can you see that? Did she leave? Anna, I'm coming at you. Anna Albritton. How many do we have between 4 and 4.5? I'll get ready. If you're watching Netflix, I'm going to embarrass you. Guys. Hunter, you want in on this?
It's 4.
4. That's right, guys. So between 4 and 4.5, we got 4. Okay. Imani, what about between 4? There you go. What about between 4.5 and 5? That's right here. Okay. Can you see how many we got?
5.
Yep. Okay. All right, and so on. So 5 to 5.5. There's 3. Okay, guys. Now look. Now here's the thing, guys. You're gonna have to read this. Okay. So if you're doing something else right now, like this is easy money on the exam, and then it's gonna be April. Okay. And you're gonna be crying because you didn't know how to do this. This is easy, guys. Like y'all are missing. Don't miss the layups. Okay. So please, I'm going to ask you how to read a histogram. You've got to know how to do this. Okay. So it's not that hard, but some of y'all, you're going to be tuning in like 20 minutes before the exam and you're not going to know how to do this. This is like an easy 5%. Like this is layup, guys. Okay. So go on and be getting it down. So yeah, between 5 and 5.5, we've got 3. Okay. 5.5 to 6, we've got 4 again. All right, and so on. All right, 6 to 6.5, we've got 3. Abigail Gibbons, what about between 6.5 and 7? How many do we have?
None?
That's right. That's right. Exactly. 0. Yep. 7 to 7.5. That's 1. Okay. And 7.5 to 8. Yep. That's 0 again, guys. So this, what we've done is we've taken those frequency of scores and we've assigned them all to different like little bins or buckets. And that generally shows us, this is 5, that generally shows us, the distribution. Y'all call this, what do y'all call this? In other words, what do you call this? What kind of curve do y'all call this?
Bell curve?
That's a bell curve, right? Okay. So guys, I want you to write this down, okay? Because this is a point of emphasis, okay? So this is a point of emphasis. Now you've got to listen because I'm not going to draw this out on the screen. It'll take me an hour, okay? But so I want you to write this down. A good normal distribution looks like a bell curve, okay? If it's a good normal distribution, it looks like a bell curve, okay? If it's a good normal distribution, it looks like a bell curve. That's a point of emphasis. Now let me go on and call y'all out. I'm not gonna, because I think this is in the other class. Now listen to me. This is how I know that some people were just tuning in like 20 minutes. Abigail, I want to be able to see your face. I just turned my camera off, so hopefully you're gonna laugh when I say this, but this is not directed at Abigail, by the way, but y'all know how I know that some of y'all weren't listening and just tuning in like 20 minutes before? Now, I think this was in another class, so let me be honestly cautious to say, y'all know what the answer was? Some people gave as an answer for one of my short answer questions in another class. Guess what it was? They gave this answer right here. POE. Guys, that's not an answer. Like that's not, okay, don't tell me POE. That's me saying you need to pay attention, okay? I'm so embarrassed. Well, yeah, bro, you should be because you tuned into the lecture like 7 minutes before you took the exam. Okay, like don't do that. Like I've just spent 6 minutes on this one slide and y'all are gonna get to April and like this is gonna be like 5 or 6% of an exam and you're gonna miss it. And Abigail's gonna be like, bro, that's the easiest thing in the world, bro. Okay, right, Abigail, is that what you're gonna do? Yeah, see, you're making that face. Yeah. Okay, hang tight, guys. Now, does anybody have any questions about that? A good normal distribution, it looks like a bell curve, okay? That's what we want to see. It looks like, you have this kind of looking curve here. All right. Okay, let me see here. Yeah, it looks like that, okay? All right. Carl, help me out. Would it have helped y'all if I'd had this larger version up here? I'm so sorry. If y'all couldn't see, I apologize. I'm sorry. Abigail, would it have helped you? No.
Not really. I mean, I could see it either way, so it doesn't matter.
Micro, like 2-point font for me. Okay. All right. So let me look here. Yeah, so there you go. It should be bell-shaped, and it should be what's called unimodal, which means that generally, unimodal means that the mean and the median and the mode all generally sit in the same kind of place. They all kind of sit right here in the middle. All right, watch out. Michael, I'm gonna put you on the spot. Unmute yourself. Michael Reichs, if you can hear me.
Yeah, I'm here.
I'll steer you through this. Now, everybody listen up. Here's a quick review. Michael, I won't leave you out to dry. Don't worry about this. I'll help you, okay? All right, guys, listen up. This is a quick little review. This is review, exam 2, listen up, okay? Michael, so right here in this distribution, we've got this kind of central place right here where like we've got the mean and the median and maybe even the mode all tend to land right here in the middle. And so maybe we get one value, we get one value that might be a good describing value of this set of data. We talked about this last week. what is that one value called? Do you-
Oh God, that was like a week ago. Sorry.
That's
I'm trying
okay.
to remember.
It's okay. It's fine. It's fine. It's fine. It's fine. It's fine. It's fine. All right. I'll give you a hint. The first word is measure. It's called a measure. Hang on. The last word is tendency.
Sorry.
Right there on the tip of your tongue. Anybody want to help them out?
Of central.
Central.
Of central. There you go.
Okay.
Okay. Guys, these are your three measures of central tendency. Right here. Okay. All right. So if you took one measure of this, it's going to tell you generally what might describe that group of data, people, giraffes, frogs, pizza slices, whatever it is. I mean, I don't know, okay? But it's a measure of central tendency. Okay, so think about it. That's a perfect example. If we have 20 of you guys here and I asked all of you, how many pieces of pizza do you tend to eat on a Friday night? Well, Carl might say 5. I might say 5. Michael might say 5. Abigail might be vegan and she doesn't eat any. I don't know. I mean, whatever. Okay. But generally, after you add up all those values, it's going to land somewhere around probably, what do you think? 3, probably, right? On average, Joe, college student. Yeah, Abigail's making a face. You're right. I mean, pretty good bit, right? Okay. So, you're going to say, well, on average, the participants in Mr. Clark's class tend to eat 3 pieces of pizza. Yeah, but what about Abigail? She eats 0. Yeah, but bro, she eats 0. Carl eats 6. Okay. Well, what about Christy? She eats 1. Yeah, I got that. But, Michael might eat 5 and it tends to come to the middle, that measure of central tendency. That's what these are. They're a measure of central tendency. So you need to know that. That's going back to review from last week, guys. Okay. So, all right. Important. You'll need to know that. Okay, got it. So now you're flipping to page 2. All righty. And guys, if I have to slow way down, it's fine. Okay. Because this stuff, like, you got to get it. So Michael, it's going to sound like I'm smacking you in the head. I'm not, but like that's a layup. Okay. So like from now on, if you're sitting around 10 years from now and you're teaching and someone says, well, you have a friend who's, or if you have kids one day and they're saying, yeah, we're learning about measures of central tendency, you can go, oh, mean, median, mode, right? Okay, yeah, cool. All right, that's a measure of central tendency. It sounds like a fancy word, but all it is one value that measures where things tend to land most centrally. Okay. All right. Got it?
Got it.
Got it. Michael, I'm going to pick on you as long as you're here. Give me one number. No, that's okay. Give me one number, Michael Rex. Give me one number. What's the average height of the people who responded to my email? What do you think? Just pick a number. It's boys and girls. It's men and women between generally 18 and 24, generally.
Like average height, like
sure.
5'8".
If I took them all and added them up, what do you think the average height's going to come out to?
Say like 5'8".
5'8". Okay, fine. I'm gonna write that down. Let's see. Abigail, you want in on that? Why don't we get Abigail's estimation? What do you think, Abigail?
5'8's pretty good. I'm gonna say 5'7".
Okay. All right. Fine. Okay. What if I told you that most of the people that respond? Watch out! Watch out! Watch out! What if I told you that most of the people that responded to my email were men? Uh-oh, she made a face.
Then I would probably say around like.
Aha!
Well, men usually tend to lie about their height, so I'm
Okay.
gonna say
All right.
like,
Okay. That's fine. That's fine. That's totally fine. Like that. But you see how that can affect it? You understand what I'm getting at? Right? Does that make sense? Yeah. Good. Yeah. Somebody's chatting me. Hang on a minute. Well, it's true. It's true, Carl. I mean, it's true. Yeah. Okay. It's true. Okay. But men might tend to lie about their height one way and women might tend to lie about the other way. I mean, you just don't know. Like, right? Does that make sense? Like, it's all, yeah, exactly. Yeah. Okay. All right. All right. We'll see you in a minute. Okay. Carl's like, damn. All right. Yeah. Okay. Okay. Let's see, next one. Yeah, there you go. Okay, yeah. And I wrote that down. Remember, guys, what we talked about, like right in here, about 68% within one standard deviation, 95 and so on. Okay, you got to know this, all right? That's right there in your paper. Okay, so we're flipping to page 2. What can affect the distribution? Okay, one of the things that can affect the distribution is the measures of central tendency, okay? Measures of central tendency, okay? All right, so if those are not aligned, okay? So you're right there at the top of page 2. If those measures of central tendency are not aligned, the data are going to be skewed to some extent, okay? So think about it, Abigail. If we were measuring this accurately, if we were measuring rather than asking, and in a class of 25, 18 of them were men and 7 were women, what do you think is going to happen to that bell curve? It might look like, well,
It's not going to be super even.
right,
'cause
it might look like that.
smaller.
Does that make sense? Right? See, because you can have a lot of contributors up here. Men are going to tend to be taller, right? Does that make sense? Yeah. Okay. Yeah. All right. Okay. The other thing that can affect it, another thing that can affect it, okay, is standard deviation. Okay. Standard deviation. Okay. And you've got this question on there about what is the relationship between standard deviation and distribution, okay? And basically, and it kind of like you got those curves down there right below it. Y'all should be looking right down the middle part of your notes. You see where it has larger standard deviation, Christy? You see that there? Okay, so guys, now listen. The larger the standard deviation, the flatter the curve tends to be. It tends to be spread out more, okay? All right, remember the standard deviation is the measure of how far the values are from the central measure. Michael, give me one measure of central tendency. Give me one.
Mean.
Mean, there you go, good job. Good job. All right, so guys, standard deviation, the larger the standard deviation, the more spread out, broad the curve is, okay?
I have a question.
Yep, go ahead.
I missed the blank. You said if these are not aligned, the data are I missed
Skewed, they're skewed.
Okay, thank
Yeah,
you.
lopsided. Lopsided. It would look like this. See, it's not
Okay.
quite, it's a bell, but it's a goofy looking bell. Okay, does that make sense? It would look like, you know, that, you know. See how that doesn't look the same rather than, you know, like a good bell like that. Okay, does that make sense, Kennedy?
Yes, thank you.
Yeah, you're welcome. Okay. The smaller the deviation, the smaller the standard deviation, the more grouped together, the higher the peak. Okay. All right. Oop, oop. Okay. So that's the second thing. So these are the 3 things that can affect distribution. 1 is a measure of central tendency. You need to know how that is. Number 2, the standard deviation. I just told you. Number 3, sample size. Okay. Now there's a question on there about what's the relationship between sample size and distribution. Okay, and all I'm going to tell you right now is that, let me think of the right way to say this. Now listen, okay, this is on page 2, bottom, okay, basically. I'm doing that really so that later on when people are watching this. Okay, so sample size. Smaller sample sizes tend to have less normal distributions, okay? Smaller sample sizes tend to have a tendency towards distributions that are not normal, okay? You introduce error into it. Smaller sample sizes tend to have less normal distribution. I'm putting this on here so later on I can remember that I'm saying all this when I go back to review this video, okay? Smaller sample sizes tend to have less normal distribution. You tend to introduce error when you have smaller sample sizes, okay? Now, take a little breath breather for a second. Just everybody rest. Kennedy, can you hear me?
Yes, I hear you.
Watch out, here it comes, watch out. I'm not gonna ask you a question, I'm just gonna show you here. Okay, so here, look, Kennedy, here's a skewed distribution, okay? You see what I mean? See, when all these are grouped together and they tend to be right in the same place, that distribution looks nice and pretty and a good little bell. But when all of a sudden you get them all whacked out, that it moves. Now, see, Kennedy, the thing is, you might look at this and think, well, that's okay. And for a lot of purposes it is, but that's still not a normal distribution, okay? This is a skew, okay? So y'all are kind of flipping over onto page 3 here. There you go, Kennedy. There's your thing. Okay. Y'all good? Y'all all right? Yeah. Yeah, and there's the thing talking about standard deviation. Yeah, I forgot that I actually give these to you. I made you write all this down, but it's still here. But yeah, a larger standard deviation is a lower peak and a wider curve, and a smaller standard deviation is a narrower curve and a higher peak. Okay. Basically represents what I already told you guys, all right? Christy, you good? Okay. Yeah, and guys, here you go. More data equals a more, there you go, more normal distribution. Now let me show y'all something here real quick. All right, everybody take a break. This may not work. Let me see if I can get this to work. Christy, what are you seeing? Still the PowerPoint?
No, Excel.
Excel, okay, I can never remember how, okay, guys, so everybody just take a break for a second. This is being recorded, so later on, guys, if you need to, now this may not work, but we'll see, okay? But let me show you something. By the way, if you have not sent me your height yet, send it to me in chat real quick in the next probably 1 to 2 minutes so I can put it in here because this might make it work better, okay? We'll see, it may not, but so if you haven't done that, send it to me, okay? Thank you, Kennedy. All right, all right. Thank you. Yeah, I see all y'all. That's okay. All right. Don't worry, Kennedy. I won't tell them which one was your entries. That's fine. Okay, good. All right. People get all hyped. People get all defensive about that. All right, now watch this. Like, look. All right, now listen. Let's remember here. What did Abigail? Abigail said, 5'8's pretty good. You know, 5'8. Okay, now watch, guys. Look right here. Let me show you something. Okay. Here are the first 5 people that responded this morning to me. Okay. First 5 people. All right. Now look, let me show you a couple things. Now you don't have to write this down, but I just want you to see how sample size affects it, guys. Here's sample. So we're going to average. I'm going to average those first 5 cells. So I'm just going to type in average. That's A2 down to A6. Now watch out here. All right. So guys, if I sent out an email and I just looked at the average of the first 5 people who emailed me back, that comes out to 5'9" and basically a quarter. Okay, 5 people, small sample size. What about if we do 10 people? Christy, do me a favor, write these down for me. So 5, just so I don't forget them. So 5, 9, that was the first number, okay? You got me there? 5, 9. Now we're going to do the first 10 people. Came out to 5, 8 and a quarter. Now we're going to do the first 15 people. Came out to 5, 7 and a quarter. Now we're going to do the first 20 people. Came out to 5, 7 and a half. I'm going to do the first 25 people. Came out to 5, 7 and 3/4. Watch this, Carl. Watch this. All right, 5, 7 and a quarter. So both Carl and Abigail were wrong, but did y'all see how, did you see how the average moved? Now, what do you think is going to happen? All right, look. As we added more numbers in, Christy, you could probably vouch, that number moved around a lot. And then what did it do is we added more numbers in. It tended to do what? Stay more in the same area, right? And guys, if we asked 10 or 12 or 15 or 20 or 30 more people, as long as they were both kind of men and women both, I bet you money we get around 5'7.5". Don't you bet? Because as that sample size gets bigger, okay, that number tends to settle more. Let's see here, it's 30. Watch this. Carl may end up being right after all. We just had another one come in here a second ago. There you go, Carl. As you're even, 5, 7 and 4/10. Okay. Yep. Now, let me give y'all a little freebie here. Okay. Well, let me show you something real quick. Watch this. Let me see if I get this to work. All right. Watch this histogram. Let's see if I can do it. Let's see if I can do a histogram here. Now watch. All right, so that's just 2. I'm going to do something here. I'm going to do 5 bins. All right, look at that histogram. So let's draw this out. Think about what that would look like. It would look like, kind of goofy looking. It would just be curving up like that. I wish I could draw on this. I don't think I can. Okay. But yeah, so you'd have a curve there. Then if we all of a sudden, if we change this histogram to include everybody, watch. So Christy, remember, can you see that curve would go up here and then it would top out? It'd be skewed. Kennedy, can you see that? See how it would be skewed? See how it would be like that? You draw a line and it go up like that?
Yeah.
Okay, now watch. Let's see if this works. If we draw it now, it's going to be kind of goofy because we got these numbers all over the place, but let's see here. I'm going to do another. I'm going to do a histogram. I'm going to do 5 bins. It's kind of hard because I don't have enough numbers here, but there you go. What does that look like? What does that look like compared to the other one, Kennedy? Let's do this. 5. Look at that. You see what happened? What happened? What does that look more like?
Normal distribution.
It looks more like a normal distribution. It looks more like a bell, right? The more people we got, adding more people to the sample did what? It brought it to a more normal distribution. You see how that works? That's every time, people. That's generally every time, okay? All righty. Now, Christy, I'm going to switch back here if I can. So let me know if this does not work. I have zero confidence this is going to work. Are we back on the sample size now?
You are.
Okay, good. Wow, I'm impressive. All right, guys. So here's the thing. Who cares? You're at the top of page 3. Why is non-normality a concern or a problem? Okay, guys. Non-normality, if your data set is not normal, it can be a source of error when you're doing statistical tests. Okay, so later on, when we're doing some stats tests, we're hoping to God that the data is normally distributed, because if it's not normally distributed, the tests get all screwed up. Okay. All right, so non-normality, that's why we care. is because we want them to be normal so that we can do statistical tests. Non-normality is a source of error. Okay. All right. And usually what is most often associated with error is a small sample size. And that's really what I want y'all to really understand, is that a small sample size is usually the greatest source of error. Okay. So think about it, Abigail. $50 says that if we took about 5 more people and we asked them how tall they were, as long as we were sort of making sure we were random, okay, I bet you money that height's going to land somewhere around 5'7", 5'7 3/4, 5'8". Okay. But if we only asked one person and it was, I don't know, Anduga, you're pretty tall, right? I think he's pretty tall. I think he is. Okay. If we asked one person and Anduga's 6 feet tall, we're like, oh, well, Anduga's 6 feet tall, so therefore everybody's 6 feet tall. And Himani's in the back like, excuse me, like, no, I'm not 6 feet tall. No thanks, right? Right. Yeah, got it? Yeah, I'm not. Okay. So you want to have a big enough sample size where you get a good representation of what's going on. Guys, I had this thing on here about one-tailed test. Don't even write that down. I don't want you to get confused about that right now. Don't worry about that. I just want you to know that usually error is associated with that small sample size, okay? So don't even worry about this right now, okay? Okay, so yeah, guys, if we have normal distributions, we can do what's called, we can normalize the scores so that we can compare them, okay? You can normalize the scores so that you can compare them. So you got that blank right there at the top. It says with normal distributions, we can normalize the scores to compare them either between data sets or within data sets or between data sets. Okay. Got it? Now look, here's the deal. Some of you guys, like, you're probably sweating because you're like, dude, he's talking way over my head. I totally get it, which is why the next time you look at this cannot be April 24th. Okay, you can't do that. Okay, you cannot do that. Okay, or unless you don't care, which I mean, which if you don't, that's totally fine. I respect that. Okay, but if the next time you look at this is April 24th, it's going to bite you in the backside. So please make sure that we get this down. Come to my office hours, ask me. I'm going to give you all some homework at some point in time. Ask me questions, okay? All right. I promise you, if you come to my office, I'll help you out, okay? Corey, are you out there? Hopefully. Is he here? He may not be here today, okay? But yeah, guys, if you come to my office, Kennedy, you had me in class, right? Kennedy, tell him I help you out, right?
Yes, you will.
Yeah, come to my office, okay? Or just Zoom or whatever, okay? All right. So yeah, we can predict the probability, the percentile of a score with normalization of data, okay? Guys, so you've got a question on there about what does normalization mean or normalize mean? All that means is that when you normalize scores, you basically, you set them up so that you can compare them to each other equally, okay? You set them up, you define them so that you can compare them all equally. You define them so that you can compare them all equally, all right, guys? So that's a point of emphasis right there at the top of page 3 about normalize. Okay, normalizing. You define them so that you can compare them. You define scores, I'm writing this down, so that you can compare them fairly and equally.
Hey, Dr. Clark.
Yeah,
Dumb question, but what does Poe mean again?
Poe, that just, all that is dumb question, that's fine. No, it's not a dumb question. No, it's fine. POE just means it's a point of emphasis. I'm telling you that so that later on, here, let me show you. If you look way up at the top of your notes at the first page. Look at your first page. You see it?
Yeah.
Look at the major concepts. What's the last major concept say? Any other what? Points of emphasis.
Gotcha.
Okay, does that make sense?
Yeah.
So all that is that I'm trying to like that, okay? All right. I had a tooth extracted on Friday. That was not very bright what I just did there. It's okay. If I pass out, y'all come to my office. It's AMG 107. Okay, but no. Okay. You got it? Does that make sense? POE? Got it? You cool? Okay. Guys, if you don't understand what POE is, just ask me or chat me. It's fine. Okay, don't be afraid. Don't be afraid. You can chat and I'll keep it quiet. Okay. All right, guys. So you're there in the middle of page 3. Just chill. Just calm down. Don't write anything down, okay? Put your pens down. Abigail, pick your pen up. Let me see it. Let me see it like this. Drop it. Put it like this so I can see you dropping it. Don't write anything down. You got
I
it?
can't
Don't write
drop
anything.
it, I'll break it.
Okay, don't break it. Okay, fine. Okay. All right. Carl, let me see you break your pen right in front of me. No, don't break it. Don't break it. You'll get ink all over it. Okay. All right. All right. So let's talk about z-scores. Okay. This is going to be a lot of talking. Just chill. Just calm down. And this is going to be recorded. All right. So let's talk about z-scores. Who in here knows the movie Jerry Maguire? Except for Christy, I'm equally disappointed in every single one of you. Okay. Like you guys, you're breaking my heart. You're killing me right now. Okay. Y'all have heard the expression, show me the money. You don't even know where the movie it comes from. Guys, go see this movie, right, Christy? Probably one of his best movies, right? Wouldn't you agree? He's great in this movie.
Definitely. They definitely need to go see it.
Cuba Gooding Jr. is great in this movie. He's great. Guys, go watch this movie. You'll laugh. When he's doing this right here, right, Christy? It's hilarious. Right? I mean, I laugh every time I watch it, right? It was back in the 90s. Yes, Carl. Yes. Before you were born. Yes. Thank you. Yes. Yes, Carl, I was graduating from college when this movie was released. So yeah. You got any more insulting things to say? That's fine. Okay, here we go. All right. Carl just added 10 questions on the exam for everybody. Right here we go. All right, so Jerry Maguire, don't write. He's a sports agent. He wanted to move to a new country, and so he was looking for a new client. Okay. Yeah, there you go, Jerry Maguire. Help me help you, Rod. Help me, right, Christy? God, help me, right? All right. And so he's wondering, who should I sign? And he's going to sign. He wants to sign the one with the most money. Now, here's the thing. Pay attention. So that I'll be rich in their country. So on your paper there, like it says, I'll be rich in their country. Make sure you write on there if you want to, like, remember, it's relative to their country. Okay? It's relative to their country, in their country. Okay? And so he posted an ad. He wants a professional athlete, send a resume, etc. Okay, simple. And so 3 athletes, guys, you're right there in the middle of page 3. 3 athletes applied for the job and they met him for an interview. And his main question was how much they would pay him to be their agent in their country, okay? Carl, you might know the answer. Think about this. Why do we care? Why am I making such a big deal about saying in their country? Why do you think I'm saying that? You have any idea? Carl?
Honestly, no.
Okay. Christy, you want in on it?
Because it's relative to.
Stop. Because it's relative. There you go. That's it. It's relative. Okay? You got it? Yeah, it's relative. I cut you off, Chris. I was just joking. But yeah, like it's relative to where they're living. Okay? Alrighty. So 3 athletes, Rob Rooney, or whatever his name is. Okay, Rob says, I'll pay you 30,000 British pounds. Anybody British? No. Art said he'd pay him 100,000 American dollars. And Yao Ming, that's a real athlete, or he was, I don't know if he's not playing anymore, but Yao Ming said he'd pay him 300,000 yen. Okay, so Carl, like, think about it. Well, no, I'm not going to ask Carl because Carl's been my little, voodoo doll. I'm so sorry. Hang on, sorry. So, Michael.
Oh, go ahead and ask. I want to.
Okay, all right. Carl, all right. Looking at these three, where do you think he's going to automatically go? As far as where do you think? Who do you think he thinks is going to pay him the most?
Honestly.
Yeah. Go knee-jerk reaction. Go knee-jerk. Don't go logic. Go knee-jerk. Go what every 12-year-old would say.
I was gonna be more complicated and be like.
No. Go ahead, but that's fine. All right. You are the weakest link, Carl. I'm putting you on mute. Okay, you're on blast. Okay, you forget it, Carl. Yeah, that was an epic failure. Michael, who do you think? Which one do you think?
Well,
Don't
the
say what Carl's going to say.
I was going to say the American dollars.
Crap.
Relevant
Okay, you're all wrong. That's fine. No, yeah. Okay. So yeah, but all joking aside, but like you have to watch out here, and you may be right or wrong. Okay, but yeah, he thinks it's 300,000 yen. It's 300,000 yen. He's my new client, and this guy's Nate Silver. Okay, this is the guy that like is a stats whiz. Like he always calls all the elections like all the time. Like. You know what I mean? Like he calls all the Congress seats correctly. He has these whole formulas. Okay, so he decides that he's going to go with Yao because Yao is going to pay him 300,000 yen. Sounds like a lot of money, right? Okay, right. So watch out. Okay. So the question is, here we go. How can you compare British pounds to US dollars to yen? Has anyone on here lived in another country where they have a different form of money? Has anyone ever done that for a consistent amount of time? Anybody lived over, or have you always lived here? If you've lived somewhere else, it's not as easy as you think to just say dollars to marks or whatever it is. Okay, like you have to know what that will get you in that country. Okay, so Nate's like, oh great, not this again. All right, so guys. Nate's going to help him out. To help you know who's going to really pay you the most, you need to find and understand the Z-score, okay? And Jerry's just saying, just show me the money, okay? Here we go. All right, now watch, guys. You have to figure out what a Z-score is. We're right down there in the bottom of page 3. Okay, guys, watch out. Now, pay back attention, tune back in, okay? You need your pen. Abigail, let me see your pen. You got your pen? Hold your pen up, good. All right, so literally speaking, a Z-score, it's just the number of standard deviations that any particular raw, I want you to write that in there, raw score is from the mean, okay? So make sure you write that in there. You guys, make sure you write in there raw, okay? Okay. A Z-score is just the number of standard deviations that your raw score is away from the mean. Michael, what is the mean? In other words, what kind of measure is that? It's a measure of what?
And I can't even remember. I'm not gonna
Measure of central.
tendency. Oh
There
yeah.
you go. Right. Okay. It's the one measure that tells us where people tend to be. Carl, you underpaid compared to the average person these days?
Not really.
Okay. All right. Fine. Okay, good. All right. Abigail, you underpaid compared to the average person?
I'm gonna say yes for the sake of this.
Okay. Well, none of y'all's making like 60 grand a year. I mean, okay. So I'm not talking about the average person for you. I'm talking about the average person in America household. Okay. Yeah. Okay. Yeah. All right. Christy, your daughter there you go. Does she have an allowance?
No, she does not.
Does she earn money to do
She,
chores?
well, she gets fed and clothed.
Aha. So underpaid, right? Has she gone on strike yet? Right. Okay. Exactly. Right. Yeah. Right. Exactly. Right. Okay. Yeah. All right. So that's the numbers. So a Z-score, it's a positive Z-score is +1 of a Z-score of +1 means that a particular raw score is 1 standard deviation above the mean. A Z-score of -1 means that it's 1 standard deviation below the mean. Okay. Now watch out. Let me show you something here really quickly, guys. Yeah, that raw score is just your ordinary score, okay? And your Z-score is a standardized score. All right, now watch out. Let me show you guys something here really quickly. I'm gonna draw it on here if I can. Guys, you may want to kind of draw this off to the side or something. Okay, but let me draw something here for you really quickly. Pretty good. What kind of distribution is that, Carl? It's a bell curve.
Normal.
It's a normal distribution. Michael, I'm going to keep coming back to you because I know you got this.
It's a normal.
It's normal. What is this number right in here? It's central. It's a
Central.
measure of what?
Central tendency.
Right. Okay. This is probably mean right here. Okay. Right. Mean. Guys, remember back we talked about, and it's on your paper on the first page, by the way, but remember we talked about standard deviations and we talked about the percentage of scores that are 1 standard deviation. Remember this number here on either side, it's a total of 68%. Remember that? Remember? All right, so from -1 to +1 standard deviation is 68%. Christy, if from -1 to +1 is 68, what percentile is from 0 to 1? Half of that.
What?
It's 34, right?
Mhm.
34%, okay? See, guys? So if a score is 1 standard deviation +1, if a score is +1 standard deviation, it's 34% greater than the mean. Got it? Abigail, does that make sense? Some? You got it? Yeah? Okay. Okay. Guys, I know it's a grind. I know. Okay. All right. Okay, so you calculate the Z-score, and I think you got that formula on there. So like guys right here, like, this is just a representation. So here's your mean of 6. This is your average of 6 right here. This is a raw score of 4.5. This is a raw score of 7.5, okay? This is a raw score of 9. This is a raw score of 3. This is 1 standard deviation, -1. This is +1. Guys, this is going to be recorded, so, if you come back later, you can look, okay? See what I'm doing there? Abigail, can you see that?
Yeah.
This is going to be beautiful. I'm going to do all this work. Okay. Man, that's pretty. I've never drawn better brackets in my life, okay? There you go. So again, look guys. All right. So your z-scores, here's your z-scores. Guys, remember we talked about your z-scores are the numbers of standard deviations away. Look, doesn't this look familiar? Look. See, 1 and 1. Abigail, does that make sense? See how they're -2, the z's. See how that works? Got it, Abigail? You good? Okay. Now, some of y'all are going to be lost from this, and that's fine. So please don't get to April 24th and miss it, because again, you get this is layup. This is like 10% of the exam right here. This is what I'm saying. Is some of y'all get math, you're like, I don't know math, and you just like stick your head in the sand. Like, I can help you. Please let me help you, okay? Or get with someone who can help you, okay? Okay. All right, so we're going to calculate a z-score. So to do that, you need to have their raw score, the group average, and the group standard deviation. That's what you do, okay, like that. All right. All right, and the formula there, it's right there. You see, it's right there. Yeah, on your paper there. Here's your z. This is the raw minus the mean, the group mean, and then you divide it by the group standard deviation. Okay, but again, I'm not probably going to ask you to really calculate this a lot. I just want you to understand what the z-score means. You see where y'all are? You're at the bottom third of page 3. Carl, you see where you are? You see that formula down there? Yep. Okay. All right. So, yeah, standard deviation. Okay, so if the group mean is 6 and the standard deviation is 1.5, yep, you're down there at that second to last bullet point. What's the z-score for a raw score of 3?
-2.
Is it?
Yeah.
Yep, there you go. You got it. All right. Who answered that? Was that who said that?
Michael.
Okay, so Michael, so if someone has a raw score of 3, how many standard deviations are they away from the group mean?
That I have no idea.
Okay, so guy, and again, Michael's he's so willing to be the the voodoo doll here, but so guys, that's the payoff. You need to know that. Like, bravo, Michael, for getting the math, but if you don't understand this, then it's lost. So guys, if it's a -2, that means it's -2 standard deviations. That is it. Okay. Does that make sense, Michael? Z-score, all it does is change it to standard. It makes it where it's, how many standard deviations it is away. That number is the number of standard deviations it is away from the mean.
I wasn't trying to think of it as that simple, I guess.
Yeah, no, keep it that simple. Like if you can do the math but don't get the z, then all is lost, because a calculator can do the math. But if you can't tell someone what that z-score means, then it doesn't matter. Okay. So you math guys, like, this is where you got to make sure you get it. Okay. And guys, if you don't know math, it's not that hard, okay? Because if Michael gives me -2 and Carl doesn't understand what it's -2, but he knows it's -2 is the standard deviations, you actually come out ahead, Carl. Does that make sense? You've got to know what that means, okay? So that value means that -2 value, the z-score is -2. That value means that it's -2 standard deviations away from the mean. So you're right there at the bottom of page 3. Michael, you seem to be working fast with the calculator, so get ready. You're going to help us out with the top of page 4, okay?
Okay.
Okay, now watch out, guys. And again, this is being recorded, so we'll go back. So back to our story. Jerry decides to calculate the z-score and offers Nate a 3.7 commission if he helps him determine which of the 3 athletes would pay him the most money. Okay, so Nate wants to get this right. All right. Remember what I said about relative to their country? Would you rather get paid a lot, or would you rather get paid a lot relative to what the average person's getting paid? Yeah, Carl, why'd you make that face? Right. It doesn't matter how much you're getting paid if you don't know relative to how much a bag of groceries costs, right? Right? Right, yeah, exactly. Okay. So you made that face. You don't even know why you made that face, but you know you made it because it makes sense now, right?
Yeah.
Yeah, yeah. If there's one thing I'm good at, it's body language, right? Okay, I can read body language. All right, so here we go. All right, so Michael, get ready because this, you probably can already be working on this, Michael, if you want. And again, I don't have the answers right in front of me, so you may screw that up. So I don't know. Okay, so Rob's going to pay him. Oh, we got Rob and Art and Yao. Okay, remember, Rob's going to pay him 30,000 British pounds. That's the raw score, Michael, for British. The raw score for American is 100,000. Okay, and the raw score for Yao Ming is 300,000. Now, Michael, you got the raws and the means and the standard deviations there. You see what you're working on? Does that make sense? Yeah. So see, now he's cooking. He knows exactly what he's doing. You should be able to bang these out. So watch this, guys. Michael's going to probably bang these out for us, I think. So, So yeah, so I gave them to you already. Here's the mean average wealth, 8,000 pounds, $82,000. There's your standard deviations, Michael. And Yao, the mean wealth is 150,000 yen. The standard deviation is 60,000. I think that should say 60. Go with 60,000 on your paper there, Michael. I think I had 6,000, but use 60,000. Let's see what happens. I might have given you the wrong number. We'll see. Okay.
Divided by 60,000.
Yeah, use 60 and see what happens. We may change it, but okay.
Like 0.3.
Okay. All right. Hold on to that. We may come back to that. All right. So what did you get for Rob? For how many? What's the z-score on Rob?
Got 11.
Yep. There you go. Raw minus average divided by the standard deviation is z-score of 11. So Carl, how many standard deviations away from the mean is Rob's offer? Don't overthink this. What? Oh,
Wait,
no,
Can
you
you
see
read?
that thing?
Can you read?
It's 11. It's it.
Oh, okay.
The z-score is the number of standard deviations, guys. Okay, that's it. End of discussion. You don't need to go any further than that. Okay.
Gotcha.
By the way, it's almost statistically impossible to have a z-score of 11. That's okay. All right. All right. So y'all write that down. That's Rob of z of 11. Okay. Z of 11. Good. Art. Got it, Michael?
It's 3.
3. There you go. We may have done Yao's wrong, so we'll see here in a minute. So that's Z of 3. Abigail, how many standard deviations is Art's offer away from the mean?
3.
3. That's it. That's it. End of discussion. You don't need to cut it up anymore. Okay. Let's see here. Let me look here. Yeah, use 60,000 and see what you get here. Let's see. I think that's what I got. What did you get for 60,000? Michael?
I'm redoing it. Hold on.
Okay. Sorry. Let's see. Oop. Carl's got a calculator. He's doing it.
I got 2.5.
2.5. Okay. All right. Watch out here. 2.5. Does that look about right?
Yeah.
Okay. All right. Okay. So that final Yao, that score, that final Z score is 2.5. Now listen. So were any of the offers bad?
No, but he picked the worst one.
Aha! Why did he pick the worst one? Why?
It's the one that would have been the lowest number. So it's
Is
that
it the
one.
lowest or is it the closest to
It's the
average?
closest to the median
Yeah, the mean. Watch
or
it.
the mean. Yeah.
Guys, it's the closest to the average schlep walking around in wherever, okay? I mean, that's just it, okay? So, Carl, who offered him the most money? But counting dollars or coins or whatever you call it, who offered him the most money, raw money? Yao offered him the most money, 300,000. Trick question, Michael. Who offered him the least amount of money? Like if we were counting pieces of paper.
Yao.
Well, but who offered him the least numbers? Okay, like it was the guy with the pounds. It was 30,000 pounds, right?
Yeah.
But it ended up, yeah. Okay. So there you go, guys. Like, what does that all mean? Yeah. So now we've put them down there. We can compare them. So which offer should Jerry take? Jerry should take the one from Rob, right? Is that right, Michael? That was the one that had the most
Yeah.
standard deviations,
Yeah.
right? Yeah. Okay. Rob, because that Z-score was 11 standard deviations away. Watch this. Now, none of them are bad because look, look here, Michael. Tell me what Yao's Z-score was. It was 2.5, right?
Yeah.
So stop me. You see this red dot?
Yeah.
Stop me when I get to Yao's score.
Hold on, I gotta pop up right there though. Yeah.
Here's Yao. Carl, stop me when I get to Art's score. Yeah, Art. Art was 3, I believe, right? I think it was.
Yeah, it was 3.
Stop me when I get there.
Stop.
Good. Here's Art. Christy, what was Rob's score?
Rob was 11.
All right, Chrissy, stop me when I get to Rob's. Yeah, Chrissy's laughing. Okay, I'll be back, and I'm gonna go make myself a sandwich. Right? Stop me when I get to Rob's score. Stop me.
About there.
Yeah, out here. Yeah, right. Okay, out here. Here's Rob. Okay, that's basically impossible. By the way, you can't do that. Okay, that's a joke of a score because that's basically statistically impossible. But look at this, guys. So look, here's a Z of 3 and here's a Z of -3. Basically, 99.7% of the data lives between these 2 points. So if he got higher than 3, he's higher than 40, basically, 49.35% or whatever that is, 75% or whatever that is. Okay, does that make sense? He's, it's a distribution on both sides. Okay. Okay. Yeah, the winner's Rob. If you move to his country, yeah, I can represent you and you can be the richest in his country. Okay, yeah. Here's Rob, my future client. Yeah. etc. Okay, that's the end. Okay, guys, now listen. So I'm gonna go. Okay, I'm gonna close for today because I want y'all to practice your Z-scores. Okay, and all I care about really is that you understand, for starters, just between now and next week or whatever, next time you can come on Wednesday, whatever. Understand what your Z-scores you get are, what that means. Okay, you need to know, if I get a Z-score of this, it means a standard deviation away from the mean of this. If you don't understand that, then you've missed the point. I mean, Michael is a good sport. Like he did. Michael, you're a math guy, aren't you? I can tell. Michael, you probably did well in math.
No, I hate
No?
that.
Okay, well, you did it really well. You got it for anybody. So, but yeah. So, guys, if you're good at calculating, but you don't understand what the Z means, then all is lost. Okay, so understand that part. Okay. So I'm going to let y'all go. I'll be here for about 5 or 6 more minutes, and then I've got to go. So if you want to calculate the scores really quickly, you can. I'll sit here with you, but then after that, I got to go. Okay. So you are free to go. This is being recorded. I'm going to stop the recording so we don't bore everybody who's watching. Okay. So I'll stay here. I'm gonna mute myself and turn my